Have you ever seen your PLC behave strangely even though the logic looked perfectly alright? That's usually because inconsistent I/O update happening during the scan cycles. I learned this the hard way until I found the CPS instruction. In this video, I will show you how CPS will lock in consistent data and fix those unpredictable bugs, especially if you're working with remote I/O racks or high-speed events. What is CPS? CPS stands for Copy Synchronous. It's similar to copy, but where it copies data from the source tag to the destination tag. But one big difference, CPS prevents interruptions while copying. Why does that matter? Because in Studio 5000, I/O updates happen asynchronously. That means input values could change mid-scan. If you are using COP instruction, the copy instruction, you might only copy part of the data structure, which can cause weird bugs. So why should we use CPS? CPS ensures copy completed atomically. That means all or nothing. In other words, PLC locks the copy operation so it cannot be interrupted midway. Either the entire data is copied or nothing is copied. A simple analogy, imagine you're copying a phone number from a whiteboard. If someone erases a digit while you are halfway through, you have got bad data. Copy lets that happen, whereas CPS instruction shuts the door until you're done copying, no interruptions allowed. No task switch or overhead time slice can interrupt it. That's a game changer when you're working with produce consume tags, input buffers, and high-speed sensors, like an high-speed encoder example. Now let's look at a real-world example using CompactLogix L24ER. What you see here is a CPS instruction. I have a CompactLogix L24ER, and in L24ER we have a input card which is of the data type embedded discrete I/O. If you go to the module define tags and look at embedded discrete I/O, it has three members and the data is of an integer data type, right? So now say we want to copy that into a working buffer. We just use CPS with a source of input card and destination. Since I know the data for embedded I/O is of type integer, I created one integer, right? Because one integer is 16 bits and I have only one embedded input card which has 16 inputs. The CPS looks like that. In this case, we are defining a inputs buffer integer and both of them match of the same data type, and we just calling it as length1. So now when we trigger this copy and go back and monitor the buffer input, when I push a button, you could see input 8 is what I wired this button to. You could see it's changing to a 1. Sorry, let me put it here. You could see that changing to 1, and some other inputs also changing. So that's how you use CPS to get a good copy of the data on the top of the logic, and then and let the PLC use that status and do the logic, right? Quick comparison between COP and CPS. COP is faster, but it's riskier. It gets interrupted. You might only copy part of your tag. With CPS, that risk is gone, but it takes slightly longer time to execute. So be careful if you're copying bunch of strings that take a lot of time. So you need to monitor the impact on your PLC when you're using CPS for copying larger arrays like strings. CPS works with any data type. CPS length is in bytes. Source and destination must not overlap. That's the key consideration. Always use temporary buffers when dealing with I/O or produce consume tags. Don't work on the raw input directly. So the best practice is have a instruction like this where you just take every scan, you take a fresh status of the input data into your buffer and refer your buffer word inside your logic. If you find this video useful, please hit that subscribe button. We got a whole series of Studio 5000 instructions, one bite size tip at a time. Now is that you understood CPS. CPS gives us consistent data every time, no surprises mid-scan. If you haven't watched our full video on COP instruction yet, check it out. I'll explain where it works great and where it can lead to subtle bugs. And coming up next, For you, the video is another beginner-friendly version, beginner-friendly video about BTD instruction. It is perfect for bit level data control. Thank you. See you in the next video.